Hi friends, welcome back. I'm Robbie Jain Mac. Welcome to my channel. If you do like my information and the videos, please do subscribe my channel. I'm here again with my new topic, fan selection and why we need a fan in automobile sector. So the basic function for the fan is to provide the airflow across the cooling system. All different types of coolers like radiator, hydraulic coil cooler, transmission cooler and charge air cooler. It provides more and more air flow across the cooling system, which dissipates the heat from the coolant, which transfers from the internal tubes to the cooler from inlet to outlet ports. So why we need the fan is, like we need to cool the cooling system. We need to cool the engine, transmission and the driveline components. So when we place the fan on engine, it also consumes the power. So it consumes power through the direct drive, like from the engine, whether from the hydraulic motor or from the electric motors. So the basic function is to optimize the airflow across the cooling system. So we will dissipate more heat from the coolers, and more flow requires the more power, and the more heat rejections will occur across the cooler. So this is the basic diagram of the cooling system radiator, where the upper hose is like placed near the thermostat. When the temperature of the radiator coolant is increases, the thermostat opens and it flow across from the cooler from top to down from the radiator tubes. And this also cools the heater hoses across the heater core, the coolant from the heater core. So basically, to cool the coolant, we need airflow across the cooling system, which we have already discussed from our basic function. Now come to the next slide, the types of the fans. So there are lots of types of fans like centrifugal, axial, but in generally we are using the centrifugal types of fan, and axial types of fans we are using in the air conditioning system, which we are using in our home application. So the centrifugal type of fan is like puller fan and the pusher fan. What is puller fan? Puller fan is like when we suck the fresh air from the atmosphere across the cooler and throw it back to the under bonnet of the engine compartment. And pusher fan is just a vice versa. It takes the hot air from the engine compartment and flow across the cooler and throw it back to the atmosphere, hot air to the atmosphere. So both puller and pusher fan is used in the application. The puller fan generally used in the application where we are running the vehicle at a very high speed or on highway application. Pusher fan is used generally where we want to eject more heat from the engine compartment to the atmosphere when the vehicle is running at a very slow condition, or when the cooling system is placed opposite direction of vehicle moving direction. And when it is placed in front of the vehicle moving direction, the puller fan is more beneficial. It depends where we are placing our the cooling system. So generally, when we go for the fan placement for air optimization, we need to calculate what is the immersion for the fan. So if you will see from the left diagram, A is the depth of the fan which is immersed inside the cowl, and D is the total depth of the fan. So percentage of the immersion is A by D into 100. So percentage of immersion is nothing like we need to immerse almost 2 by third times of the depth of fan for the puller case and 50% in the pusher case. So why we need and the another criteria which we need to maintain is fan tip clearance. Fan tip clearance is nothing like if you will see the third diagram, bottom side of the right, you will see like the 1 inch gap we have given in the design from fan to the cowl. So basically the how to design the fan tip clearance is like it's generally 2 to 3% of the fan dia. So if suppose your fan dia is 600 mm, you need to have minimum tip clearance of 12 mm across the radial gap. So this is about the fan placement for the air optimization. Generally fan immersion improves the fan across the cooler because it sucks more and more air When your fan immersion is 2 by 3rd, it will give you the optimized air across the system with the same power consumption. Now we'll come about the fan power loss. What is fan power loss? So the volume or the flow across the cooler, it depends on the speed of the fan as well as diameter of the fan. When you increase the diameter of the fan, the flow increase almost 3 times of the cube. When you increase the speed, it increase proportionally. So what is affinity low? Flow is directly proportional to the RPM of the fan. Pressure varies in the square of the speed. Like if you increase the flow, or if you increase the if you increase the speed of the fan, the pressure drop increases almost twice. What is if you see the curve, there is a static pressure drop across the airflow. When your static pressure drop is 0, your airflow is very high, and when your static pressure drop increases, your airflow decreases. So what is the power consumed by the fan is like nothing but 2 pi nt. 2 is the 2 into pi, and is the speed of the fan, and T is the torque consumed by the fan through direct drive or external drives from the hydraulic motor or the electric motor. To optimize the fan for required airflow with less power consumption is most important to design the fan or to select the fan. The static pressure drop across the fan will reduce the airflow, so it is recommended like the static pressure drop should be very less. So your restriction across the cooler or behind the BIR restriction across the system should be very less. If your restriction is very less, your airflow will increase directly with the same power consumption. So there are lots of types of the cooler available in the market. Sometimes this is inline cooler, sometimes it is staggered cooler. So inline cooler is nothing but placing the radiator, transmission oil cooler, charge air cooler, and every types of cooler inline to the system. If you place inline to the system, suppose your airflow is Q across the fan, so Q1, Q2, Q3, Q4 will divide accordingly to the inline cooler based on your restriction. It is not directly proportional to the area of the cooler or width of the cooler, but it directly proportional to the restriction. Where the restriction is less, more airflow pass through that particular cooler only. So your Q1 plus Q2 plus Q3 plus Q4 is total airflow which fan is sucking from the atmosphere, and your Q1, Q2, Q3, Q4 directly depends on the restriction across the cooler. So if we will go back to the slide, you will see like there is a puller kind of fans. So generally there are different types of cooler also. We have talked about the inline cooler. There are staggered types of cooler also. So we will discuss about that cooler in our next part, why it is required and what are the main function for the fan, and how we need to select the fan, and what happen if we select high speed fan, what will be the noise problem will occur. So if you like my video, I will give you more information. Please do subscribe my channel. Thanks for this video. Thanks for watching this video.